Good morning, Math 30s. We are continuing our unit on transformations, and in lesson 1 we were introduced to horizontal and vertical translations. This lesson is going to be a review essentially of lesson 1, and there's going to be one new example later on. So this, if you open up your workbooks to page 83, we are going to be doing lesson 2 on page 83. It's horizontal and vertical translations part 2. So let's just quickly do a quick review of what was introduced in lesson 1 with horizontal and vertical translations. So you're going to be given a function, and we call all of our functions y is equal to f of x. So f of x is just function notation. What happens is we are going to translate this function horizontally, which is a left-right move, or vertically, which is an up-down move. There's two parameters associated with these translations. So an up-down move, which is a vertical translation, that is our k parameter. So what I do is I take the original function that I was given, and I could write y minus k is equal to f of x. Now, I always tell students, like, when you get really good at this, you always want to visualize k on the left-hand side because that's how they'll often write the equations. However, just realize that that is the same thing as if I add k to both sides, y is equal to f of x plus k. Okay, so that's how we do a vertical translation. If k is greater than 0, your graph moves up, and if k is less than 0, your graph moves down. Now, the h parameter is your left-right move. Okay, so the h parameter is your left-right move, and this is what we call within the function. So within the function. So my function is right here, and if I want to insert my h parameter, then I'm going within the function. So if I now want to do a horizontal translation, it's going to be y is equal to f of x minus h plus k. Let's just say h here, it was x minus 8. H, remember, is 8, and that is a horizontal translation, 8 units right. Okay, so let's look at class example 1 and 2, which are going to be reviews from yesterday. So write the replacements for x and or y and describe how the graph of the second function compares to the graph of the first function. Okay, so what we have here is we have y is equal to x to the power of 4. That is our f of x, right? And then what they've done is in the transformation, they did y is equal to f of x plus 3. So hopefully that you could see this and you could say, okay, that plus 3 is my k parameter. So k is equal to 3. That's a vertical translation, 3 units up. Now, we're going to be doing something called replacement notation for x and y. So what they're doing is they're saying, okay, we know that the k parameter affects the y, right? So what they're actually replacing is they're replacing y with y minus 3. And I'll show you what I mean. What you do is you take your original function. So y is equal to x to the 4. Then we're going to do our replacement. So take y out and put in y minus 3 is equal to x to the 4. And then from here, to get what our transformed function is, we know that to get rid of that negative 3 to isolate y, we're going to add 3 to both sides. So that's going to be y is equal to x to the 4 plus 3. Okay, let's do b next. Okay, so let's do b next. What we have here is we have our original function is 6x minus 3. And then if you could see, so there's our x. They've taken the x out and they've replaced it with x minus 1. Okay, is what they've done. So let's write our replacement notation. What they've done is they've replaced x with x minus 1. So in our original function, y is equal to 6x minus 3. what they've done is they've taken this x out and they've replaced it with x minus 1. So what we're going to get is y is equal to 6 x minus 1 and then minus 3. Okay, you need to be able to look at that and you need to say they replace something within my function, right? This is within the function. So is that an h parameter or is that a k parameter? Hopefully you're able to say that's an h parameter. This h value is equal to 1. What that tells you is that's a horizontal translation, 1 unit right. Okay? Okay, here's our function. It's an absolute value function. Y is equal to the square root of x. They have done two things to this. To this function, they're adding 2. That is our k value. And then within the function, they are subtracting 6. So they're doing two things to my original function. So the first one I'm going to do is I'm going to do the replacement notation for the k value. Okay, so again, this is the original function. This is the transformed function. So the replacement notation to get this k value equal to 2 is y is going to be replaced with y minus 2. That's the replacement. So again, watch what we do. Take your original function. Y is equal to the absolute value of x. What we are going to do in that original function is because I want my k value to be 2, I'm going to take out this y and I'm going to put in y minus 2. Okay, so take out the y and put in y minus 2. So y minus 2 is equal to the absolute value of x. Okay, from here, we could isolate y, right? So we could say y is equal to the absolute value of x plus 2. So that is my k value now taken care of. K is equal to 2, and that is a vertical translation 2 units up. So maybe I'll write that down. K is equal to 2, vertical translation 2 units up. Okay, now what we have to do is this is our function where we're at, and we need to insert an x minus 6. So what I need to do is I need to take out this x here, and I need to put in an x minus 6. That's the replacement. So x is going to be replaced with x minus 6. So let's take our function where we are at. Y is equal to the absolute value of x plus 2. And now I'm just going to simply replace it with y is equal to the absolute value, replace the x with x minus 6, and then we'll say plus 2. That is my transformed function. And you might want to make a note that let's talk about the h value here. So just let me move this down a bit. Okay, so to talk about the h value now, it's within the function. H is equal to 6. That is a horizontal translation, 6 units right. Okay, our last function is d. So let's look at d. Y is equal to 1 over the square root of x. So I'm just going to erase this. Okay, so that's our function there. And what they've done is they've replaced the x with the x plus 1. So they said take out your x and replace it with an x plus 1. So you write your original function, which is y is equal to 1 over the square root of x. And what they're going to do now is they're saying, okay, for my transformation, let's replace the x with x plus 1. So I'm hoping you're seeing and you're getting used to that this right now is within the function. So that's going to be an h value. So that is an h value, which is -1. So the parameter h is -1. That is a horizontal translation, 1 unit left. Some students would say, okay, well, how is that not a k value? If it was a k value, what they would have done is they would have said like outside of the function. They would have put the -1 there, or they would have put a +1 there. That would be outside of the function. This is within the function, so it's replacing x. Okay, so that's something called replacement notation. Class example number 2. Write the replacement, so another replacement notation for x and or y, and hence the equation of the image. Okay, so the equation of the image, that's after the transformation, right? Would be the equation of the image. So the original function is y is equal to x squared, and they want a horizontal translation of 3 units to the right. So we know that a horizontal translation is our h parameter, and if they want it 3 to the right, h is going to be equal to 3. Now, a horizontal translation, that is an x replacement. Okay, so for your translations, it's either going to be an x replacement or a y. Horizontal replacement is an x replacement. Now, remember that the replacement is not x with x plus 3. That would be incorrect. The replacement is going to be x with x minus 3, and I'll show you why. So here's our original function. So you write down the original, y is equal to x squared. Then we're going to do the replacement. So what we're going to do is we're going to take out this x, and I'm going to put in x minus 3. And I'm going to put this x minus 3 in a bracket because it's more than one term. So y is equal to, so take out that x and put in its replacement, x minus 3. This is your new function. So that's the image, the equation of the image, which is the equation of the translation. And x squared is a parabola. And if you graphed x minus 3, what you would have is you would have that h value is now 3, which is a horizontal translation 3 units right. Okay? Okay, this is our function, y is equal to 10 to the power of x. They want a vertical translation of 2 units up. That is a k value. They want k to be 2. So what they really want, if this is my function, I'll show you right now what the end answer would be. They want the original function plus 2, right? That's going to be the answer. But the question says they want replacement notation. So how we get this final answer is we're going to take out y. Our k parameter is a y replacement. And what we're going to replace it with, y is going to be replaced with y minus 2. So again, just to show how we got that final answer, you take your original equation, which is y is equal to 10 to the power of x. After it undergoes the transformation, the y comes out and y minus 2 goes in. Y minus 2 is equal to 10 to the power of x. From here, I would be 100% okay on a test if you box this in, but I'll accept that, or I'll accept if you want to isolate y, because we wouldn't be able to put that in our calculator unless y was isolated. So y is equal to 10 to the power of x plus 2. That's my original function vertically translated 2 units up. Okay, let's look at C. Y is equal to, so we're getting a radical function. Y is equal to the square root of x. Two things they want to happen. So the two translations, they want a horizontal translation of 4 units to the left. So h is equal to -4, okay? That is an x replacement. X is going to be replaced with x plus 4. So let's take care of this one first. There's our original equation, y is equal to the square root of x. Then horizontal means within the function. So take out this x and put in x plus 4. And what we would get is y is equal to the square root of x plus 4. So right now, what I've done is this is my original equation, and this is now my transformed equation, and what it's been translated is 4 units to the left. Then what they want me to do is they're saying, okay, and a vertical translation of 3 units down. So I know that's my k value, and k is -3, right? They want to take my equation and they want to go 3 down. So I know there's going to be a -3 on the end here, but how I get that with replacement notation is y is going to be replaced with y plus 3. Okay, take your equation where we're at, y is equal to the square root of x plus 4, and let's do our transformation. So our transformation is taking out y and putting in y plus 3. So y plus 3 is equal to the square root of x plus 4. All right, from here, we could keep that as our answer, but I want to isolate y. So y is equal to the square root of x plus 4 minus 3, and that's what I'll box in. So this original function underwent two transformations. It's going 4 units to the left, horizontally translated, 4 units to the left, and 3 units down. Okay, flip to class example 3, and we will do this one. We're only going to do 2 in here. Okay, and again, this should be a review. Class example 4 is going to be the new one. Okay, so for class example 3, the function represented by the thick line, so this function here, that's the transformation. Okay, so this is the transformation. And the original function was the thin line. So what it says is it actually gives me the equation, but I'm going to write it over here. Y is equal to the absolute value of x. That is our original function. Then it's going to undergo two transformations actually to get translated down and to the right. So let's figure out what the transformations are. So I'm going to use this vertex as my point, and this vertex goes 1, 2, 3, 4 down. So 4 units down and 1, 2 units right. Okay, so a translation 4 units down. So we know that that's going to be k is equal to -4. The replacement, though, is y is going to be replaced with y plus 4. So you're given your original function, y is equal to the square root of x. And after the transformation, take out that y and put in y plus 4. So y plus 4 is equal to the absolute value of x. Y is equal to the absolute value of x minus 4. So what that is it's this original function translated 4 units down. Okay, now we have to take care of 2 units to the right. So 2 units to the right, we know that they want h to be equal to 2. That is an x replacement. And what are we replacing x with to go 2 units right? Do you think I'm going to write down x plus 2 or x minus 2? Hopefully everybody says x minus 2 is the replacement. So I take my function where I'm currently at, right? That's where I'm currently at. So y is equal to the absolute value of x minus 4. And now let's do the replacement. Take out that x and put in x minus 2. Y is equal to the absolute value of x minus 2 and then minus 4. There is my new transformed equation. That's the transformed equation of this thick line here. Okay, so that's the transformed equation of the thick line here. And the original equation underwent 2 transformations. It went 2 units to the right and 4 units down. And remember, you have to understand, you have to be able to write this replacement notation. So I'm just boxing in what the replacement notation was. Okay, let's do the same for this guy. So this is a parabola. This is my original function, and they say, please call the original function y is equal to f of x. Now we know that that equation would be, because it's just a parabola, probably -x squared, but we have to use what they give us. So they're not going to give us the equation of the parabola, they just say y is equal to f of x. Okay, so what are our transformations going to be? From vertex to vertex, I'm going to go 1, 2, 3, 4 units up. So the first transformation I'm going to go is 4 units up, which is a k value. Then I'm going to go 1, 2, 3 units left. 3 units left, which is an h value. Some students would say to me, Mrs. King, could I have counted it slightly different? So for example, could I have started with the h first? And I would have said absolutely. Starting with the h first, you'd go 1, 2, 3 units left, and then you could have counted 4 up. You'll get the exact same answer. Okay, so it doesn't matter if we start with the h or the k. Okay, what would your replacement be for going k is equal to 4? So that's a y replacement. So are we replacing y with y minus 4 or y plus 4? What does everybody think? 4 units up is going to be y minus 4. Here's the reason why. Take your original function, which is y is equal to f of x. The replacement is to take out y and to put in y minus 4. So let's see what we get. Y minus 4 is equal to our function. If I isolate y by adding 4 to both sides, I get my function plus 4. That is taking my function and moving it, translating it vertically 4 units up. Okay? Now let's do within the function. So an h translation is within the function. So that is going to be an x replacement. Now ask yourself again, if I want if I want h to be negative 3, what's my x replacement? It is x plus 3. So take your function where it is. Y is equal to f of x plus 4. We're going to replace x with x plus 3. So y is equal to f, and I'm going to take out that x, and I'm going to put in x plus 3. And that would be the equation of your image, the equation of your transformation, after it undergoes a vertical translation 4 units up and a horizontal translation 3 units to the left. Okay, class example number 4 is our last class example, and then I think I'm probably going to do number 7 with you. But number 4, what it says, oh, sorry, I want you to star this. So this is new, okay? This would be what I call SE, which is a standard of excellence. And when I star things, I will always put it either on your quiz or your exam. So you guys know you're going to have a quiz coming up when you return, and this is going to be a quiz question. Remember that I always give an A and a B version for my quiz. So like half the class will be writing one very similar to this A, and half the class will be writing very similar to this. So you just want to make sure that you're able to do both of these. Okay, so y is equal to the square root of x, they tell us is a radical function. No problem. What vertical translation? So I want you to underline vertical translation, and then I want you to write down, okay, is that your h value, your h parameter, your k parameter, and that's your k value. So we're going to be figuring out the k value. So what vertical translation would be applied to this function so that the translated image passes through 16, 7? Okay, so what's the transformation so that the translated image passes through 16, 7? So essentially, on this original function, we're going to have a point, and then that point is going to be translated to 16, 7, and they're wondering, like, what was the k value to get to this? Okay, so the thing is, if we're doing a k value, that's a y replacement. So I want you to write down y is going to be replaced with y minus k. So take your original function, which is y is equal to the square root of x, and then you say, okay, they want us to find out the k value. So what we're going to replace is y with y minus k is equal to the absolute value of x. This is our transformed image, right? This was my original image, and this is my transformed image. We need to figure out what the k value is. In order to figure out the k value, I need an x value and a y value on my transformed graph, and they gave that to me up here. Up here, 16 is my x, and 7 is my y. So let's take out the y and the x, and let's put in those numbers. So 7 minus k is equal to the square root of x. Sorry, x is 16. So let me just take that out and let me put in 16. So 7 minus k is equal to 4. We're not square rooting both sides, so I'm just going to take the principal square root, which is 4, and then isolate k. Add k to both sides and subtract 4 from both sides, and you would get k is equal to 3. So that's my k value. And this is a vertical translation, 3 units up. So you want to tell me what the k value is. You want to tell me what the vertical translation 3 units up would be. And then my new equation would be y is equal to the absolute value of x plus 3. Okay, and that would be my new equation. Okay, B. What horizontal translation would be applied to this so that the translation image passes through that point? So again, when they say what horizontal translation, you say to yourself, they want an h value, right? They want an h value. And they're giving us an original function, x comma y, and then they're saying, okay, what h value is going to be applied to the x to get my new point to go through 17 comma 8? So your h value, you have to ask yourself, was that an x replacement or a y replacement? And that was an x replacement. So x is going to be replaced with x minus h. Take your original function. So y is equal to the square root of x. And let's do the replacement. So take out x and put in x minus h because we're figuring out a horizontal translation. So x minus h. There. We need to figure out what this h value is. Okay, so in order to get that h value, you need to plug in an x and a y, and they gave us an x and a y on our transformed image. So this is going to be our x value, that's going to be our y value. So let's replace our y with 8 is equal to x minus h. So x is 17 minus h. Okay, from here, let's solve for h. So this was radicals. To get rid of a radical, we're going to isolate the h, but we got to get rid of that square root sign. You're going to square this side and square that side. 64 is equal to 17 minus h. And what I would do is I'd bring h to your left, and I would bring 64 to your right, and then you will get h is equal to negative 47. Okay, that is a horizontal translation, 47 units left. The replacement would be x is replaced with x plus 47. So take your original equation and the transformed equation, you want to take x out and you want to put in x plus 47. So my new equation is y is equal to x plus 47, and that would give me a horizontal translation 47 units left when h is negative 47. And actually we should box in that h is negative 47. Okay. Here are your homework questions. We'll do 7 together. And remember that your quiz on translations, it's going to be from the workbook lessons 1 and 2, and it's going to have, it's going to be homework questions that you've done, and I'm just going to be changing numbers. Okay, so let's quickly flip to number 7, and let's do this one together. Let's figure out why I have this one starred. Okay, the graph of the function y is equal to f of x passes through that point there. So the original function, it's saying passes through this point. So y is equal to f of x. It's going to pass through that point. Under a transformation, the 0.47 is transformed to 6 comma 6. 6 comma 6. Okay. And then what it says is a possible equation for the transformed function is. All right. So they want us to take that equation y is equal to the absolute value of x, and they want us to figure out if that's the original or a point on the original graph, and this is a point on the image graph, what transformations are happening. Okay, so we could either look at our y's first, or we could look at our x's. I'm going to look at my y's. Now, remember that your y value is associated with your k parameter. So what's happening with our y? It's going down 1 unit. Down 1 unit. That is a k value. K is equal to -1. This whole lesson, lesson 2 in the workbook, was on replacement notation. So in order to get a k value of -1, the replacement is y is going to be replaced with y plus 1. Okay, so if this is my original graph, it's going to be replaced with y plus 1 is equal to f of x. Because then if I subtract 1 from both sides, I'm going to get y going down 1, right? So far, this looks to be correct. But let's check our x replacement next, okay? So our x replacement is, it's going from 4 to 6. Okay, so our graph, our x coordinate is going from 4 to 6. That is 2 units right, right? If you're going from 4, an x value of 4 to an x value of 6, you're going 2 units right. The replacement is an x replacement if it's an h parameter, and 2 units right is going to be x minus 2, right? Because we want our h value to be 2. So what I need to do is I need to take my graph where I'm at, and we're going to take out x, and we're going to put in x minus 2. So y plus 1 is equal to f of, let's do a replacement, x with x minus 2. And that is our new the equation of our image graph or a transform graph. This graph is going 2 units right and 1 unit down. So C is in fact your answer.